Hi, in this video, we're going to talk about balanced and unbalanced forces. So, Newton's first law of motion says that an object at rest will remain at rest, and an object in motion will remain in motion with the same speed and direction until acted on by an unbalanced force. Let's look at that last phrase today and ask this question. What causes objects to change their motion? Naturally, objects don't want to change their motion. They want to keep doing what they were doing. But what causes them to actually change their motion or accelerate? The answer is an unbalanced force that is a net force. A net force is an unbalanced force. So a net force is necessary for any object to accelerate. We can state it even more clearly. Net force causes acceleration. Objects don't naturally accelerate. They naturally just do what they were doing. They don't change naturally. A net force causes objects to accelerate. And that's also why net force and acceleration are always in the same direction. So let's look at some situations involving acceleration. Oh, ouch. I need a better place to put my whiteboards. Okay, so when all the forces are balanced in a situation, the net force is zero because all the forces balance out, and therefore the acceleration is also zero. Remember, net force and acceleration are connected. You need a net force to cause acceleration. So an example of this would be a book at rest on a table. A free body diagram shows that gravity pulls down, but the normal force balances the gravity. There's zero velocity here because the book is at rest. The net force is zero, and so the acceleration is also zero, and so the book remains at rest. Pretty simple. Let's look at another example where it's maybe not as clear based on what you might think of when you see force vectors. This one can be a little tricky, but follow me here. Let's say we have a frictionless air hockey table and an air hockey puck is moving to the right, no friction. It's already been hit, so at this point it's just moving and gliding across the table. When we draw a free body diagram for this situation, the only two forces are gravity pulling down on the puck and the normal force from the table, or really the air, supporting the puck from falling. There's no applied force because nobody has pushed, someone pushed it originally, but now it's just gliding on its own. So it will continue in motion based on Newton's first law. So there's no applied force, there's no friction. So these are the only two forces acting, and they are balanced. The velocity is to the right, the net force is zero, and so the acceleration is also zero. This means that the puck moves at a constant speed to the right. Now let's look at some situations where the forces are unbalanced. So when the forces are unbalanced, the net force is not zero anymore. And that means the acceleration is also not zero. If there's a net force now, and that means there is going to be some kind of acceleration. It's going to either speed up or slow down or change directions. So let's say you're going to your local mini golf course and you putt a ball. So as you're hitting the ball, you apply a force on the ball to the right. The ball also has some weight, and the ball is also supported by the green. The normal force balances the weight. So these two forces, normal and gravity, often balance each other and cancel each other out. And all that's left over is the applied force to the right. So the velocity is to the right. The ball is moving to the right. And the net force is also to the right. You're pushing the ball to the right. The acceleration is always in the same direction as the net force because the acceleration is caused by the net force, so it is also to the right. So the ball is moving to the right, and you're pushing it to the right, so the ball is speeding up. It started at rest, and you're bringing it up to speed. Now let's say the ball has now left your club and is now rolling down the green on its own. As it rolls towards the hole, it slows down and stops before it reaches the hole. In this case, the forces acting on the ball are still gravity pulling it down, normal supporting it, pushing up on the ball. But now we have a frictional force to the left, and there's no more applied force because you're not hitting the ball anymore. You've let go of the ball and it's now just rolling on its own. So there's only friction acting to the left. The ball is moving to the right still, but friction is acting to the left. So the velocity is to the right. The net force now is to the left. It's the leftover force to the left. And that means the acceleration is also to the left. So it's moving to the right, but it's accelerating to the left. That's slowing down in physics language. So that's all I've got for you in this video. Remember, happiness is not having what you want, it's wanting what you have.